Hi there guys, my name is Charles Welsfan Msipa, as you can see written on the screen. Yeah, I'm your e-tutor for XAT 1512, and the students for MAT 1512 can benefit from this discussion if they are interested. Okay, my aim of this presentation is to discuss your tutorial 1 and making some comments on where I think we need to emphasize some points concerning understanding computation of limits. So let's start straight away and look at the following exercise. Like you can see your question, first question 1-1, you were supposed to state whether this statement is true or false. But of course, this is a very short question. There are a lot of things which are hidden behind scenes here, which you must think of when you are doing this exercise. So let's start by looking at 1.1. So you are required to show that to state whether this is true or false, that the limit as x tends to a of f of x is equals to f of a. Of course, here the answer was given as true, but what is behind in this short statement is that this is true if, first of all, a is in the domain of f. In other words, f of the value f of x is a defined value, because otherwise, if it's not, that is not the case. That is, if f is not defined at a, then we've got a problem. Let's see this kind of a situation. Suppose that f of x equals to x squared minus 1 over x plus 1, and we're required to calculate the limit as x is approaching minus 1 of this expression. The limit of this exists and is not equals to f at minus 1, because first of all, f at minus 1 is not defined. So in that case, this won't be true. Let's calculate this limit just to show that this limit exists. So surely if we look at this to do direct substitution, we can see definitely that this is going to give us 0 over 0, which is an indeterminate form which we cannot give as a limit. So factorizing this, we get the following. Sorry, not a, but minus 1. Limit 10 to minus 1. Factorize the numerator, we've got x plus 1, x minus 1, it's difference of 2 squares, and then over x plus 1. So we can see that this simplifies to limit as x tends to minus 1 equal of x minus 1, which evaluating directly gives us minus 2. Now this is the limit of this function, and as you can see, is different from f of minus 1, because it's not even worth saying it's different, because actually this is not defined. Obvious in this case, then minus 2 is obviously different from anything which is not defined. So behind this statement where you say it's true, you must understand that this is true only when a is in the domain of the function and f is meaning that f is defined at a. And when I say f is defined at a, basically mean that if you evaluate f at a, you get a value which makes sense. But if you evaluate, like for example in this case, you evaluate this f at minus 1, you can see that you get this, and then this is an indeterminate form. Then we say that f is not defined, and after all, minus 1 is not in the domain of the function. So that's why when I'm saying that you mustn't just say it's true here without understanding this kind of a background. Now coming to number 2, I think the answer was false here, and it's clear why it's false, because you can see here there's a difference of two functions here, and this side is the sum of the limit. I think it will be only true if with the same sign here, like minus there. And then coming to number 3, number 3 was false again, I think for the obvious reason that on the right hand side, this side, the limit is calculated tending to A, but on the left hand side is calculated tending to C. And then coming to number 4, again, this will apply, this will be true if the limit of f and that of g exists, then we would get this product too. I think in that question, as far as the question is concerned, that's what I wanted to make a comment on, that you must sort of not lose sight of these facts. Now coming to number 2. Now number 2 again, let's say 2.1. Looking at 2.1, if we look at 2.1, we've got two functions which are involved here. In this case, we can say h of x, which we can give as x cubed plus 2. And this is a polynomial and is defined everywhere. And then, which means this x, which is the value of 3, where x is tending to, is in the domain of this function. And then it will satisfy exactly what we said before. In this case, the limit of h here, the limit of h as x is tending to 3, it will be equal to h at 3. And similarly, if we call the next expression g of x, which is x squared minus 5x, again is a polynomial, so, and the 3 is still in the domain of that, then it will again be a limit as x tends to 3 of g of x will be equal to g of 3. And since these will be defined values, because these functions are defined everywhere, obviously the product will be defined, and then the limit just ends up being the product of these two. Then you would say then limit as x tending to 3 of x cubed plus 2 in brackets multiplied by x squared minus 5 would then would be simple h of 3 multiplied by g of 3, evaluating directly in those expressions. Now coming to the 2.2, yeah, the one thing which I want to make a comment about here, when you are presenting your solutions, it's always advisable to write the initial expression which were given. In this case, for 2.2, I would write limit as x is tending to minus 4. But just check something here. I think there was kind of a misprint here, something got in here. I don't think this is supposed to mean that calculate limit as x tends to minus 4 from the left, but I'll just take it as computation of a limit as x is tending to minus 4 of of x plus 4 in absolute value of x plus 4 over x plus 4. Now, dealing with this kind of expression which involves absolute value, one must never lose sight of the definition of the absolute value. Let's say if we're talking about absolute value of x, we know from the left to the right, we can say it is minus x. Now, as I'm talking about from left of the number line, minus x when x is on the left of 0, and x when x is 0 or on the right of 0, which I call it greater or equal. So when analyzing this limit, you really need to reflect on this, otherwise you might not get it correct. So in this case, we're going to this function is defined in piecewisely. So here it tells us that we're going to have two cases, one case for this situation and the other case for that. So this is how we go about it. So now we can say now case 1. For case 1, consider x plus 4 less than 0, which means then in this expression we're going to substitute this by minus x plus 4. In other words, the limit is going to be limit as x tends to minus 4 of minus x plus 4 over x plus 4. So then doing direct substitution here, what we're going to get here is we can simplify this as limit as x going to minus 4 of minus x minus 4 over x plus 4. Now substituting directly, I think we can see that this would give us minus 4 minus 4 over minus 4 plus 4. For in the numerator, they will get plus 4 minus 4, which is 0, and the denominator also got 0 over 0, which is an indeterminate form. Now, on the other hand, if we now look at the next case, which in this case, the case number 2, for x plus 4 greater or equal to 0, then this will be limit as x going to minus 4 of x plus 4 over x plus 4. And then this again gives us minus 4 plus 4 over minus 4 plus 4, which is again is an indeterminate form. So then what you can conclude here is just to say, therefore, the limit as x tends to minus 4 of the absolute value of x plus 4 over x plus 4 does not exist. I hope that helps. So please, some people write in a very strange way solutions to exercises. Please always start your solution from the expression which is given and develop your solution nicely. Sometimes people write solution just to show above what they're given and what follows the solution. But even if you don't give it, but it must be clear where are you parting from or what you are given. Like for example, we've got some let's say like when the limit exists, somebody just state that number 2.2. Let's say the limit for this was about a 4. Somebody just write 2.2 and say the answer is 4 without showing any working. That is not acceptable in mathematics. Please develop your solutions step by step and show all the essential steps so that you don't lose marks. Definitely, if in the case this answer was 4 as a limit of that, if you give it this way, this won't make any sense. And first of all, you will give it like this without even the expression which was given, just give an answer. That's not acceptable, please guys. Okay, so let's proceed to the next exercise. In this case, we've done 2.2, then we go to exercise 3. Now, you are given here the function, and you are asked to determine the left-hand side, the the left hand limit at 2 and the right hand limit. So I think what we can see, what we can do, if we also understand the graphs of this function, we can actually illustrate graphically that the limit of this function does not exist. But how? Let's say we can sketch a rough sketch of this diagram like this, and have our number line here. This is 2, this is 1, and that is minus 1 there, and 1 there, and 2. Now notice that on the left hand side of 2, this is actually a straight line which cuts at minus 1 and the 1 there, and then which means that 2, this function is not defined, so leave an empty circle there. Then the line roughly will be going like this. Then on the right hand, at 2 and on the right hand side of 2, the function assumes this expression of the parabola. Now at 2 itself, it is basically evaluating here as 2 squared minus 8 plus that, which is give us 10, and then it will be 2. Then we've got the value of the function there. Then let's just suppose that the graph maybe will probably go that way roughly. Then we can see that as we approach 2 from the right, this value of the function will be approaching the value 2, which is at that level. But when we approach 2 from the left, the values of the function will be approaching that level of 1. So we've got 2 and 1 there, then which shows basically that these two limits are not equal. Then we can illustratively show this shows that the limit does not exist. Maybe this statement here was supposed to show that the f of x does not exist, because it is what we get is actually the opposite of what we were supposed to show here. Now, on the other hand, I would like to share with you also the idea, another idea of showing that this limit it does not exist, especially for this left hand side of 2, because x is not in the domain of this expression. It might not be very accurate to evaluate this at 2, like you take 2 here, subtract, you get 1, because this x will never assume the value of 2 anyway. So what trick can we use here? We can use some construction of this nature, like we can say 2 minus 1 over n. Now n here is unnatural numbers 1, 2, 3, and so on. Now notice that this expression, let me just call it some kind of xn, is a kind of is a sequence, actually not a kind of, is a sequence. As n, let's say for n equals to 1, you can see you're going to give 1 over 1, then 2 minus 1 is going to be 1, so that you'll be somewhere there. Now for n equals half, for n equals 2, then this will be 2 minus half will be 1.5, which is somewhere there, which is closer to 2 than that. So as n is approaching infinity, this value is very small. Now the term itself here will be coming closer and closer to 2. So now if we now say f at 2 minus 1 over n, substituting here, we'll have 2 minus 1 over n minus 1, which when we simplify by removing brackets, we're going to get 1 minus 1 over n. Now coming back to this kind of situation, we see that as n is growing towards infinity, this term actually becomes negligible, and then which means the difference here will definitely approach 1. So there it is. the limit on the left is 1 and on the right is actually 2, and at that point actually this is a polynomial, is defined, then the limit is equal to the value of the function there. That's it. So that's another way we could have shown that this limit does not exist, not that it exists. It doesn't exist, because now what happens now is the limit as x is tending to 2 from the left of f of x is clearly different from limit as x is tending to 2 from the right of f of x. Therefore, the limit does not exist. Now, proceeding to exercise number 4. In exercise number 4, looking at the solution, of course, it says the f of b exists. You must understand that f of b exists definitely means that the f that is this value is defined. That's what it means. And then the next 4.2 is given, basically stating that the limit of f of x as x tends to b from the left is equal to the limit as x tends to b to the right, which we've also talked about that. And then lastly, the very fact which you stated before, that for the limit of as x is tending to b of f of x must be equal to the value of the function at that point. Yeah, this is what I wanted to share with you, and just highlight some of the points that I've shown you here, so that when you do these exercises, you mustn't overlook some of the facts which are very, very important for understanding the issues of limit. Otherwise, at this point, I would like to say thank you for listening. I shall also be posting a presentation on assignment 2. Any comments, you can send it to my email, which you can see on the screen.